Hello, welcome to another stunning Max 9 tutorial. This is tutorial number 23, multi-track looper. What are we going to do? Well, we are going to have two tutorials, I believe, and in this one, we're going to build a single track of our multi-track looper, and then because things are so easy to duplicate in Max, then we will go ahead and build and duplicate it and make the multi-part of the multi-track looper. Sound good? Of course it sounds great. So we're going to employ some things that we've already used, like buffers and such, but we're going to play a little bit of a different game with the multi-track looper. And so what we're going to do is get a new object here, and we're going to call it SF record. And why SF record? SF means save to file, record. And what's useful about saving something to a file, and of course I'm leaving this here because I'm just going to go get one out of the help file, but what's useful about saving it to a file is that then it gives us all sorts of information when we open the file into a buffer. And we'll use that to our advantage. So sorry about the long intro here and lack of action, but let's spring right into the action then. I just wanted to tell you why we were doing this crazy thing. So here we go. Option clicking on that, we get the help file. Ooh, it looks great, doesn't it? Unlock the help file, steal everything. Command copy, close that, and if it asks whether you want to save it, you say negative. I do not want to save anything into my help files. We delete this one, we put in the other one, and now we have some instructions, which is always nice. And we'll go through the instructions now, easier for me, and probably more sensible for you, and we'll point out some important things about the SF record, because it's going to save to a file. So let's lock this patcher momentarily, and we'll start at number 1. It says open. So when you open something in SF record, it means you're creating a file that it will record into. It's sort of saving, like, it can't just save into a file. You have to open it and tell it what file it's going to be saving into. So let's click open. We get our helpful window. This is my Max 9 tutorial patches, and we're going to save. Now remember, we're not saving the project, we're just saving the first sound that this thing makes. So since we're going to have to duplicate them, let's just call it something really simple, like A1. How's that? That is the name of my file, A1. And if you're on a computer and it doesn't seem to put an AIFF there, that's okay. It probably means your computer prefers to work in like a WAV file or something, and you can actually save them as different things. They're mostly fine, but you want them to do it automatically. So whatever it comes up as automatically, you probably want to stick with that, because that's probably what's native to your computer. So let's just go ahead and save that, again, into a file that Max can find on your computer. Okay, now, there's nothing there right now, but once we record something, there will be. Okay, done with number 1. Number 2, start the audio. Bonk. Look, it's audio, and the meters are going up and down. Great. Now, we've turned on Max. Max is hooked to our microphone. If you're not getting anything here, go up to Options, go to Audio Status, and make sure that your input device is the one you want. I have a nice Yeti stereo microphone. I prefer to use that. I have a built-in, but it's a little more of a, sounds like a tin box in comparison. I like this nice full sound. And then your output device should be your output device. There's sometimes are options with what the audio driver is, and that will depend on your computer. I believe on my Mac, I can either use Core Audio or this other version, Add Port Audio, Core Audio, which is more for using when you're doing complicated things. If Core Audio works, use it. If it crashes, use something else. But don't change anything there if it doesn't need to be changed. You want your input device, your output device. That's what's important. Put that away. Make sure your microphone is turned on, which is blue, and then you can see the meters going. So far, so good. And now, the big moment, when we record. So let's go ahead, think of something interesting to say today. I love making micro multi-track loopers. It's the most fun I've ever had. Okay, now, did it work? We think it worked. When this thing turns off, it should create the file, and the file should have been saved somewhere. Okay, so now we're going to go look at our file, and here's our Finder. Right up here, there's the Max 9 that we just saved into. We scroll down here, and there it is, A1. On a Mac, you can check these things out by just pressing the space bar. I love making micro multi-track loopers. It's the most fun I've ever had. Okay, so we know the file's there and we are good to go. So back to Max. There we are. Let's, now that we've learned all these wonderful things, let's take this and stick it up in the corner because we're going to get, okay, so we'll get rid of this. We'll get rid of these two because they're cute, but we don't need them. This is just stuff we don't need. We don't need any of this either. There we go. It is, however, nice to know that our recorded track will be 7,941 milliseconds long. Okay, so what we want to do is use Groove for the looper, but to play Groove, that means you have to have a buffer. So let's type N, we'll type buffer, and a little tilde. If you can't find the tilde, just go ahead and click down here so that you don't have to find it. But if you can find tilde, that's fine. All right. And now, knowing that we're going to make a 4-track looper, let's say, I'm going to call this buffer Johnny 4. Johnny 4. No, not Johnny 4. Johnny 1. 1 out of 4. Now, in the names, you cannot have a space, right? So even though I called this Johnny 1, that is one single name, no spaces. Because now I'm going to put a space, and I'm going to say, okay, I'm going to now have, it's going to be stereo, so I want to put a 2 after it, okay? And that is going to be my buffer. And then what we want to do is somehow put the file that we just made there into here. Little trick with buffer is there's other ways to do it. You can tell it to read or open things, whatever, but I always use the command replace. And I use replace because that means it fetches all the information that's with the file and resizes the buffer. If anybody in my class remembers, when we were setting the buffer sizes in the last exercise, sometimes they would be bigger or smaller than the recording, and so they'd have remnants of the old recording. And this is one way to get around that. So if we lock our patcher now and hit replace, we can go and get our A1 file from our Max 9 file. Mine just sprung right up there. So nice of it. And then open that. And if you remember, the trick with a buffer is you can double click on it and you get the window. This is probably somebody saying, I love making multi-track loopers. It's my favorite thing on earth. Something like that. Old Johnny 1, the robot, said. Okay, so there, we've got the buffer and, well, let's put it, where to put stuff. You know, you never know. Where is it going to be handy? Okay, so now the next object is going to be groove. So new groove tilde, if you can find it. And then you, of course, want this groove to have the same name as that buffer. So for me, Johnny1, for you, your namey, diminutive, cutie, namey 1. Or A, if you like. It's all fine with me. You do you, but don't do me, okay? Agreed. So, 2, number of outputs. I don't know why I went through all the trouble to do that, because I'm just gonna, because I'm gonna do this, and I'm gonna do this, which is get it out of the help file again, because I love having all this stuff and Signal and all that stuff, and I don't have to go and do it myself. So unlock your patcher, grab all this stuff, copy it, close your patcher, don't save it, and then delete this one, though you've put so much effort into it, paste your new stuff in there, drag it down here, and let's start examining what we have. But right away, probably what we want to do, well, there's a help groove buffer. Oh, no, let's not mess with it. Right away, we can come in here and say, Johnny, or your namey, 1, space, 2. 2 outputs. But this is going to be the number 1 track. And when we have a Johnny 2 and a Johnny 3 and a Johnny 4, that's going to be 2, 3, and 4 track. Okay, very good. So the weird thing is that I always love how there's one thing missing here. And it may be the most important thing ever, which is the ability to stop. So I'm just going to make a message here, stop. Make sure it's not capitalized. Capitalized doesn't work, even though it seems more emphatic and or desperate. Okay, so we're building a looper, so what we're going to want it to do is loop. If we say the word loop with a 1, that turns looping on. If we say the word loop with a 0, that turns looping off. So we could make another message with loop 0, but instead of doing that, we're going to just jump right in here and say, and put a $sign in front of that. And what this means is loop string 1. Whatever's coming in here, we're going to call string 1, and we're going to put loop in front of whatever it is and send it down to groove. In this case, we're going to make a toggle by typing the letter T, and the output of a toggle, as we know, is either a 1 or a 0, as it says there, whether it's set on or off. And so we will be able to turn our looping on and off. Fantastic. Okay, so right now, loop is on. Right now, loop is off. Okay, and reviewing another thing, Groove is called a signal-driven device, or a signal-driven sample player. This is the signal, and if you're sending it 1, it's going at normal speed forward. If you're sending it a -1, it's going normal speed but backward. If you send it a 0.5, it's going half speed forward, etc., etc. And if you send signal a 0, it just pauses. It just kind of stops. Now, that is in distinct comparison to sending a 0 to Groove. groove, when it gets a number, it says, that's where I'm going to start playing, but in milliseconds. So 0 means start playing at the beginning. Thus, we had to put the stop on here so that it interprets stopping as correctly, because if we turn this on at 0 and it's looping, we'll never be able to stop it. But here we go. Here's a 1 for our signal. I'm going to turn the volume up a little tiny.
Multi-track loopers. It's the most fun I've ever had.
Right. Thank you, Johnny 1. And in reverse, and if we put it in reverse, it doesn't know what to do because it is at 0. So it would have to be, we'd have to send it to the far side of that and have it play backwards, I believe. But in this case, we can say 0 and it'll...
I love making micro multi-track loopers.
I wonder if we can change in the middle of it.
I've ever heard enough.
Yep, you sure can. There you go.
I love making micro multi-track.
Interesting stuff, right? Stop. Okay. And the one last thing is, let's make sure our looping works here, though I am somewhat tempted to make a shorter recording. Okay, we can bear it. Here we go. 0. Go forward.
I love making micro.
So there it is. It's definitely stop. Now I'm going to turn the looper off and start it over again.
I love making micro multi-track loopers. It's the most fun I've ever had.
And it stops, just like it should. So we have everything working here, and now we can take another short break here to clean things up. We notice that this is the minimum loop point, but we know that. We've done this before. And this is the maximum. I moved it away from maximum. Goodbye, maximum. And we can get rid of the buffer that was in the help file because we're not using it, and our groove is not named like it. And there we go. And there we go. What we have to do, we're just going to pull this out here a little bit so we can work with this, is find a way to make this particular looper loop and give us some feedback about where it is in the loop. This is just one of those things you need with loopers. So this outlet is the loop sync outlet. And I'll show you, and this, oh, this is the other channel out. Oh, interesting. This looks like a monophonic gain control, so we'll just send them both out the same outlet. That's fine. And I didn't realize I made my groove stereo, but the gain is not a stereo gain. That's okay. Doesn't matter. But over here, what we want to do is see what this sync is doing. So we're going to go up here to numbers and click that open. And then you see we've got the number I for integer, this one F for float, and this one, you may recognize that little tilde there. This is the number for signals. So we're going to pull this down here and stick this under here and connect these up. But I do insist that before we hook this up, that I get to record a new a new recording, so we don't have to listen to that long one, just something easy. So here we go. We're going to open this. We're going to come down here. We're going to call this A1 again. We'll overwrite it if we have to, for crying out loud. Overwrite it? Yes, we're going to overwrite it. And now we're going to record just something simple. Here we go. 1, 2, 3, 4. Nice. I'm going to suffer every time I hear it, but at least we've got it. So here we go. hitting the... Oh, this, it should have saved it. Oh, we have to, believe it or not, replace this with the same thing. There we go. A1, open. And now, let's play it. Come on. Come on. We can see it. 1, 2, 3, 4. Why not? Oh, maybe we had this on. Oh, there it is.
2, 3, 4. 1, 2, 3, 4.
Okay, great. So I'm going to turn that down a little bit so we can bear it. And what you can see is it's counting from 0 up to 1, and then it starts over. So this is a great thing. No matter what size... Okay, let's stop that. No matter what size the loop is, this thing sees it as one whole recording, and it only goes from 0 to 1. So this is super useful for us, because then that tells us that all we have to do is figure out when it's changing from 1 back to 0, and we'll be able to say, bang, that's where it's, that's where the end of the loop is, in case we want to synchronize all the loops later on. And then we can also rest fairly well assured that we can just use a dial or something to represent 0 to 1. So, first order of business is that we have to figure out what it is that happens that tells us that it's time for a bang. In other words, we have to figure out what it is that's happening to this number. And of course, we know what's happening. It's going up to 1 and then it's going back to 0 and starting to count again. But it's never really that simple. Like, is there a mathematical function that says that? What we're going to do is, let's type a new object here, and we're going to say greater than tilde, and then a really tiny number, 0.001. Okay, so why? Because we don't really know precisely how this thing's going to count digitally. If we had this thing, say, equal to 1, it may fire, but we don't know that it's looping. In this way, we know that it has in fact looped and has started back again, and so we can have it fire something. So we're going to connect this to that. Now that counting is going to come through here very nicely, and now we need something that says, okay, if this is greater than 0.0001, what's going to really... This is going to change from a 1 to a 0. Is it greater or is it not greater? So most of the time it's going to be 1, and then it's going to change to 0, and then it's going to change back to 1. And there is a device that detects when it's changing, and that device is called edge tilde. Okay. So this is all... I know this is somewhat abstract, change detection, but just for the sake of argument now, we'll, you can just type the letter B to get these buttons, but they're good for letting you know when something's going on. Okay, so now, with a little tiny bit of volume again, and locking my patcher, I'm going to play this.
1, 2, 3, 4.
Bonk.
1, 2, 3, 4. 1.
See this?
2,
that's not me
3,
going click.
4.
It's a recording of the
2,
click
3,
of the mouse.
4.
Okay,
1,
turn that down.
2, 3.
So, using either one of these, in all probability, we can use this to say, okay, this is the signal that should sync up the other tracks. Now, stopping this so that we can concentrate, we can also do another thing, which is we can put a new, oops, unlock your patcher, type the letter N, and just type dial. And we click and we get a dial, and I'm going to make this real big so we can just look at it. Okay, this is not exactly the dial that I would imagine would be good for a looper. For me, a loop is 360 degrees. So let's go up here, degrees used in the circle over here in our inspector. Well, let's make it 360 degrees. We're powerful people. We know what we're doing. And then maybe we want the circle width percentage. The thickness of this line. Well, that's only if there's an arc going around here, and you can make that a greater amount or a lesser amount. Let's just say we make it greater so we can see it. So now that makes it a fatter line. It depends on whether that's what you want. I myself would like the, let's see, what's indicator? Oh yeah, indicator. Some people might like that. I like pie slice, I believe. Pie slice. Well, you know what? We'll hook these up running and then we'll check. But I think pie slice is what we want here. Now, we also need to adjust how big this is, because as you can imagine, since it's a max object, it's going to go 0 to 127 in all probability, or have 128 range. So let's go over here and look at it, scroll down, and sure enough, the size of it, the number of steps in the range, is 128. Okay, so we want to make this only go from 0.0 to 1.0, but to do that, it will keep correcting us because it won't allow 1 until we float the output. So we're going to float the output, and then we're going to come up here, double click on this, and say 1.0, right? So now it has a range of 0 to 1.0, and it's has a float output. Wouldn't it be better to just, we'll just hook this up so it's running, and then we'll look at the different, possibilities. Oh, I had clicked hide on lock here. I just unclicked it. Sorry to get off track. We'll just hook this up here to the right hand. Let's move this over here so we can look at this here. To the right hand outlet here. The left hand is a signal number, and the right hand is a regular float number. So let's lock our patchers and probably turn down the volume. We've got the loop on. Let's go ahead, make sure it's 1 and 0.
2, 3, 4. 1, 2, 3, 4.
Nice.
1, 2.
Go backwards. All right, so turning this down, what we promised was we were going to unlock the patcher, take a look at this. I like the pie slice, but you can also decide that you want to do some classic chunky rectangle moving around in there, or needle, or live version. There you go. Or pan, I don't know. Oh, I see. That's a little confusing because it suggests that you're going halfway around and then switching something. So back to arc. There's your arc version, which is fine. They're all good. There's the indicator, and here's the pie slice. I like the pie slice, but that's just me. Okay. Let's stop this for a minute, locking our patcher, and stop. Okay, so now we have something here that can tell us how to synchronize with other things. We've got this that's going to tell us how everything's going. Now all we need is an automated system for telling this whole thing that every time we record something new, that we want to record something new, it's going to overwrite this buffer, save the file, open it back in this file, etc. Does that make sense? Of course it makes sense. So we're left with a question here, which is, we want to automate this whole thing, but we have these two things that that need to get done here. This needs to open a file and tell SF record where to record the file to, and this one needs to tell buffer Johnny1 where to go get that file that just got recorded, right? So we need a tool to make some dialogues in the background while we're not looking, or at least to do it once and then we don't have to do it again. There is such an object, and unlocking my patcher and hitting new, it's called save dialog. Come on, save dialog. There it is, second one. Save dialog. And what you do with a save dialog, let's put a little button above it, and a message below it. All right. So you remember I was using A1. So here we go. For our save dialog, what are you going to do, you crazy machine, when I ask you to do that next time? You're going to, first we're opening this, and we're going to go right to our A1 file and save it. Yeah, sure, replace it. But now look what it's gone and done. It's given us the exact path for that file. And so now we could say, we can take this message here and say, all right, SF record, I'm going to send you this. I'm going to prepend it with an open. Here, let me move the buffer over here. I'm going to prepend it with open and send it right in there to you. Okay? So we'll put a new thing. We'll say prepend open. Okay? And then I'm not saying we're going to do it at the same time. I'm just also moving this out of the way. You know me. Always. But we have to do a similar thing for buffer with replace. So let's just copy these and move them over here and connect this up the same way. Get rid of this message that's hiding back there. And say instead, oh, we have a prepend. There it is. And instead of open, we're going to say replace. So far, so good. Okay, two messages. They won't trigger yet because nothing's triggered them, but this one is going to go to the buffer, and we can get rid of that. And this one is going to go right over. No, I didn't tell you to do that. This one is going to go right over here to SF record. Okay? When they get triggered. So, who's going to do the triggering is the question. Well, let's imagine that we're going to start off with a toggle like we have here. And let's just drag this one over here and see if we can interrupt the whole process enough times that it makes sense. So when we hit a 1, the first thing we need to do is to send it this and say open, and then send it something that says record, just like this X would. That's what I really mean to say. So let's type a new object, whoops, unlock our patcher, type N, type trigger, and then the second thing it's going to do that we said is going to send it a 1, which means start recording. But the first thing it's going to do is send out a bang. I believe I'm correct about this. And I'm doing it backwards because trigger, as you may remember, goes from right to left when it's firing. So the first thing that happens when something comes in here, the first thing that happens is bang, then 1. Okay? So the bang is just going to come down to this and bang this message in there. And then the second thing is going to be 1. Say, hey, start recording. That is going to be the same as this X doing that. So I'm going to just connect that here and connect this to that. Okay, that's how we're going to start the recording. And then when we want to stop the recording and we turn the X off, this is going to output a 0. Oh, I've missed an object. Here we go. New, select, my goodness. 1 space 0. Getting ahead of myself. Okay. When this is clicked to 1, this will send out a bang. That will go to this trigger. Now we're getting somewhere. And when it sends out a 0, that will come out here, and it will be very similar to this, but it will need to do different things. And what are those things? It will need, first of all, to say shut off SF record. That'll be a 0, and then it will say you want to say take this file that I just got done recording and slam it into this buffer. Okay, so it's going to be 0 and then bang. Very much like this one. Not quite though. So new trigger. What did we say? Bang. Second. 0 first. I wish they did this a different way. Why not left to right? But it's right to left. I'm sorry. That's the way it works. Okay. So first thing it does is send out a 0 to SF record to stop it from recording. I am going to Command Y that to get it to be neat. And then it's going to send out a bang to this to replace the buffer. Is there any chance that this thing will work? Let's just see real quickly. And I guess so that we can't mistake it for our previous counting from 1 to 4, we will lock our patcher and say the first 5 letters of the alphabet. You ready? Here we go. Recording. A, B, C, D. All right. And turning up the volume here since I was trying to keep it low. Let's see how we did. A, B, C, D. A, B, C, D. It is a miracle. That is a miracle. So what we've done here is make something that can automatically save the file, and then when it loads it back in here, it knows how big it is. This thing's going to be all ready to run. Everything is ready to go. Well, I would venture to say that we have accomplished a lot in this tutorial, and we will be back to turn this into a 4-channel looper in the next tutorial. So here it is. Thank you all for watching so much. And now I can do this. Thank you all for watching so much. Thank you all. Thank you, everybody. I'll see you in the next tutorial. Thank you all for watching so much. Thank you all for watching